Good evening everyone. Today we are going to do the daily Leetcode challenge of 27 January 2023, that is question number 472, concatenated words. We are given an array of strings without duplicates and we have to return all concatenated words in the given list. And what is a concatenated word? It is defined as a string that is comprised entirely of at least two shortest words in the given array. Let's understand by example what they are trying to say. So in the example, what they want to say that there's a word called cat, there's a word dog, and when cat dog are combined, it becomes cat dog. So cat dog is the concatenation of cat and dog. Concatenation means adding of words. Cat plus dog is added to form cat dog. That is what they want to tell you. And you have to return this concatenated word if there is any in the string. So in this case, cat dog was the concatenated word available, so we returned it. So this is all you have to do. So please try to think around the question and think of an approach and try something and then come back to the video. So if you have tried the most easy solution which should have come to your mind, that we will have a blank string and then we have two choices, whether to include cat and whether not to include cat. Then after that we again have two choice, whether to include this dog to make it cat dog, and whether we should not include dog, that then it becomes cat again. And in the blank string then we have another choice, whether to include dog and whether not to include dog. So ultimately you will get some answer and you will backtrack and see whether they are in the string and you will get the answer as cat dog. But if you see the time complexity in such cases, we have two choices for every element, for every string element. So the time complexity will be exponential, that is 2 to the power, and for the brute force. So will that be a optimal solution? No, because it is a brute force solution and it is having very high time complexity. So we should optimize it. So please try to think an optimal approach which is better than this. Okay, and then come back to the video. So I hope you tried thinking of an optimal approach, but if you was not able to find out one, see the video. See what we can do. We can think of this word as cat and we will divide this word into prefix and suffix. Prefix is C and suffix is at. And we will make a set, and inside that set we will check whether we are having a prefix C. The set will say no. Then we will move on. Then we will make a prefix as CA and suffix will become T. Then we again check in our set. It will say no. And then we finally get the whole word cat. And we are not finding overall word. So we will neglect it. After that we will move to dog. For dog, prefix initial is D and suffix is OG. We will check in set whether there is a word like this. No. Then we will check DO and then we will check G. Then again it is not in the set. Now it will start to make sense. When we move to cat dog, we will check one by one. First we will check C, then at dog, then CA, then T dog. Then when we will check cat, we will say that our prefix is in the set. Cat word is in the set and other word is dog. That means our suffix is also in the set. That means cat dog is the answer. But let's say there is another condition when you are not having this dog here. You are having D and you are having OG separately. And then you have this cat dog word. In that case, this suffix will not be there. So is the answer wrong? No. It is still the concatenation of rest of the strings. So what we will do, we will divide this suffix again to our function. We will pass this suffix to the is concatenation function, which will be checking whether it is present in the set or not. And we will pass this word dog into it. And now this dog will be divided D and OG. And we will check whether it is in the set. Yes, D is in the set and OG it is also in the set. So then it will return true. So ultimately our answer will become cat dog. So that is what you have to do. You have to make a concatenation function which will check whether it is a concatenation or not, which will divide the words into prefix and suffix. And when you are dividing the words into prefix and suffix, you have two conditions. First is either prefix and suffix both are present, or the concatenation of suffix is present. That are your two conditions. So let's see in the code and you will understand it better. So let me just zoom it for you and we will start coding. So coding this is pretty much simple if you have understood the approach till now. What we will do, we will start with creating the int equal to words dot size. This will give us the size of our word string. After that, we will make an unordered set of string, and we will name it as st. And what we will do to get all the words inside this set, I will give you a shortcut, that is begin comma words comma end comma words. This will get all the elements from this word string into our unordered set. It is an inbuilt STL call of C++. After that, you will make a string result to store our result. And we will start iterating in the loop as I told you, I less than n, I plus plus. And inside that, we will get our first word. Word is equal to words dot I. This will give us the first word, that is cat in the second example as I told you. And after we have gotten this word, we will check it in a is concatenation function. Inside that function, we will pass our word and this set. And this set will tell whether it is true or not. If it is true, we will push it to our answer. We will push the word to our answer. And if it is not true, it will not push to our answer. After that, we will return a result string. That's all you have to do. So now let's complete this is concatenation function. To complete this function, what we can do, what will be the data type of it? It will be a boolean data type because we have to return whether it is true or false. We will check. First, we should pass the parameters. What will be the parameters? First, you will pass the word. So for passing the word, you will write string word. And next thing you have to pass is unordered set. That is, we will check in the set now. That's why we are passing set, and we will pass it by reference to avoid any time complexity issues. And after that, you will make a int n is equal to word dot length. This will give us the length of the words, and we will start iterating. For int I is equal to 0, I less than n, I plus plus. Now, what I told you, we will make a prefix, string prefix. And how to get the prefix string? We will simply use the STL call that says word dot sub str, and we will pass the starting index and the initial ending index. That will be the total length of the ending index. That will give us the substring prefix. And for suffix, what you will do, you will write word dot sub str. Sub str is a STL call which will give you a substring where you have to pass the starting index and ending is in this length. Length you have to pass. And after that, suffix will be I plus 1 up to end. And for end, you don't have to pass anything. You leave it blank and it will consider it from that index to last index. Now, what's the next thing I told you? It is the most important part of this question, that we will check whether our prefix is in the set. If it is in the set, then it is very good. And also we will check whether our suffix is in the set or not. And we will check whether our suffix is in the set or not. If these two conditions are true, will that be enough to complete our answer? No. We also have to check for the condition when we are having elements like these. Yes or no? When the concatenation is of other parts, when we have to devise this suffix and then we have to check the concatenation, as I told you by giving this example. So to write that condition, we will create an or. Or if this is true, or we have to check whether our prefix is in the set. That should be the first condition. Prefix should be in the set. That's our important condition. Also, we have to check whether is concatenation. We have to pass the function again, and we will check it for suffix. We will pass the suffix and we will pass the set, and then we will check whether it is true or not. Then we can say true or false. Yes or no? Return false if it is not true. So what is happening here, as I told you in the example, the first case is of this, when suffix was in the set, cat and dog was in the set. But the next case is when the suffix is divided into parts and then it is part of the concatenation, when D and OG were different. That condition is covered here. First is suffix is part, other is the concatenation is the part. That's what we are checking. So let's just run and check whether it is working or not. So yeah, it is running. Let's just submit it. So yeah, it is accepted. But one thing to notice here, what will be the time complexity? It is a loop of O n. It is O n loop. Okay, that's fine. But when you run here in this loop, you will see that it is running for n times, and when you are calling this function again, then it is running again n times. So it will be like, let's say it is running for m times and m into m. That is what is happening. And if it is called again, it will be the m square to the power square. That will become m power 4, and that will be a huge complexity, and but it is still less than exponential time complexity. But we should reduce it. How can we reduce it? Can you think of any way? The best approach to deal with such condition, when we are calling the is concatenation function for again and again, we can already store it somewhere, and that concept is called memoization. I used to call it memorization because it is basically memorizing the steps which are done. I don't know why it is called memoization. If you know, please comment it. So for that, we will create an unordered map which will store what? It will store the string and its value, that whether it is already done or not. And we will have to also write here that if it is already found in the string, we will check whether it is true or not. Map dot end, then we return map dot word to our function, and this is true, and we have to make here return map dot map word to true. This is basically the storing of data to avoid calling the same function for the same element again and again. It reduces our complexity to, it will change our m power 4 to m power 3, because there might be cases when we do not have to call this is concatenation function again, because we already found the word in our map. And we also have to declare our map here by clearing it, and then rest is alright because we have declared it globally. So let's try to run this and check whether it is working or not. So yeah, it is also accepted. So this is the memorization way or memoization way to reduce the time complexity. Generally they won't ask you such time complexity, but if they ask, you know the answer, how time complexity is calculated and how it is reduced, and what is the benefit of this memoization here. So I hope you liked the video. To brief you with the question again, we simply had to return the concatenated words, and for that we just check whether we divided the word into suffix and prefix, and we were checking whether suffix and prefix both are present, or whether the concatenation of suffix is present, and prefix should be there in any case. If prefix is not there, then it is not concatenated. And further we optimized it by using memorization by creating an unordered map to store the strings already done, so we don't have to call this is concatenation function again. So this was all you have to do in this question. I hope you liked the video. Please like, share and subscribe. Thank you so much for watching. Bye bye.